Hello students, this is the continuation of the chapter Reflection of Light. In the first part we had learned about the spherical mirrors, plane mirror, the reflection that is happening through spherical mirrors and some rules that you have to follow while drawing the ray diagrams for the spherical mirrors. Now in this video we will be learning about the ray diagrams, that how the ray diagrams are made, how the point image is obtained and what are the different types of ray diagrams. Now here we have two ray diagrams of a concave mirror. In the figure A, we can see an object AB is placed between the focus and the center of curvature of the concave mirror, that is M and N. The incident ray is A and Q starting from the point A, that is our object, and going through the focus. And it becomes a parallel to the principal axis after reflection and it returns along the QR. So this is our ray. The incident ray AS is parallel to the axis. After the reflection passes through the focus and returns along the path ST, it cuts the reflected ray QR and it is cutting where you can see it is cutting at A dash. Okay, so it is meeting at A dash. Now this image of A is obtained at A dash and the point B, which is situated on the principal axis, its image will also be on the axis and will directly be above the A dash. Thus we can say that the image of B is at B dash and the image of point between A1 and B1 will be formed between the points A1 and B1, and thus the image of AB is A1 and B1. And as you can see, AB was an erect image. The image that you will get, that will be an inverted image, and also your image has been magnified. Earlier the object was small, but A dash B dash, the image that you have got after reflection, the image is more, it has magnified itself. Now look at figure B. So an object is placed, the object is AB and it is placed between the pole and the focus of the mirror. The incident ray is AQ and is parallel to the principal axis, and the incident ray AS is in the direction which is joining A with the center of curvature. So in the figure you can see that how these rays gets reflected and forms the image A dash B dash of the object. And where you can see the image is, it is behind the mirror. So the image is behind the mirror, it is erect, it is larger than the object that we have. And as the reflected rays, they do not meet up, so they appear to come together, and we see that they are meeting behind the mirror and the image is a virtual image. So our first image, as it was formed in front of the mirror, so it is called as, and in the image which is always in the front is called as the real image, and the image that is formed behind the mirror is called as the virtual image. So we have two types of images, real image and a virtual image. Now let us see how the image is formed for a convex mirror. So as in the figure we can see AB is our object and it is kept in front of the convex mirror, that is MN. Then incident ray AQ starting from A and traveling parallel to the axis, that is AR, going towards the center of curvature. And this is how the rays get reflected from the image A1 B1, and we can see that how the reflection is being happening here. So from this we can say that the image which is formed is smaller than the object. It is behind the mirror and it is erect, and as the reflected rays do not actually cross one another, the image is also called as a virtual image. Now one thing you have to remember about the convex mirror is that the nature of these images which are formed by the convex mirror, they does not depend on the distance of the object from the mirror. So these images are always virtual, they are smaller than the object, and they are always situated behind the mirror. Now, concave mirror is also called as a focusing mirror. This is because, as it is shown in the figure, that the parallel rays, they get focused after reflection in the mirror, and the size of the image which is produced by these mirrors can be larger or they can be smaller than the object. It usually depends on the distance of the object from the mirror. And for convex mirror, you can see that it is a dispersing mirror. This is because the parallel incident rays get dispersed after reflection in the mirror, and the size of the image produced by these mirrors are always smaller than the size of the object. Let us now understand the main concept of this converging and divergence. Now the image produced by a plane mirror is a virtual. This image is produced at a point from which the reflected rays appear to diverge, and this image cannot be obtained on a screen as the rays do not actually meet there. So when light rays collected at a point after reflection from a spherical mirror, they are said to converge there. So that is why we use spherical mirrors to converge and diverge mirrors. We never use plane mirror for converging and diverging because in plane mirror it does not happen. So when we want to bring light rays together at a point, that we call it as a converging beam. So we use a concave mirror. The doctors use such a beam to converge light on our tooth, ear, nose, etc. Then equipments like solar energy also use a converging light. Then next we have is the convex mirror. So when light rays starting from a point spread out after reflection by a spherical mirror, so light is said to have diverged. You can see it is diverging. So when we want light rays to spread out from a source, so a divergent beam is used. For example, we can say street lamp. So now what can be the uses of concave mirrors? So as it is a converging mirror, so it is used at barber shop, dental hospitals. So what happens is if the object is placed between the pole and the focus of the mirror, so an erect, virtual and a magnified image is obtained. So this is the reason why we use a concave mirror in these places to get a magnified image. Then the concave mirrors are also used in torch and headlamps of vehicle. So the source of light is kept at the focus of the mirror and thus we can get a parallel beam of light. It is also used in floodlights because it gives a bright beam of light. Then it is also used in various equipments of solar energy because the sun rays reflected by the concave mirror, they will come together because of the converging property in the focal plane. So that is why we use concave mirror for all these places, and also it is very beneficial. So now what can be the uses of convex mirror? So these mirrors are on the sides of the car. They are all convex mirror. The big convex mirror are also fitted in some shops so that you can get the image which will be a virtual image. So that is why we use convex mirrors. Now there are few sign conventions which are called as Cartesian sign conventions. So according to Cartesian sign convention, the pole of the mirror is taken as the origin, the principal axis is taken as the x-axis, and the sign conventions are, there are 5 sign conventions. The first one is that the object is always kept on the left of the mirror. So all the distances which are parallel to the principal axis are measured from the pole of the mirror. Then second, we have that the distance measured towards the right of the pole are taken to be positive. So you have to always remember that right is always positive, while those measured towards the left, they are always negative. Then distance which are measured vertically upwards from the principal axis, they are again taken as positive, and which are measured downwards, they are taken as negative. So remember that which are on the right side, that will be positive, which are on the left side is negative, upward is positive, downward is negative. And the focal length of the concave mirror is negative, and if it is a convex mirror then the focal length will be positive. So these are all the sign, the conventions that you have to remember, which are called as the Cartesian sign conventions.